And there is our optimal design. It's a rectangular prism. It has a cutout of 1.58 inches squares on each of the four corners. And this is a designed optimization based on generalizing the cutout of the squares as follows. Using the rectangular prism as the design base, recognize that we have to have square cutouts at each of the corners, starting with a raw material of 8.5 by 11 inches. Those square cutouts can be generalized with a variable, let's call it x, and assembling the web into the net into a three-dimensional shape creates the rectangular prism with the height of it determined by the cutout x. And then notice that the length, we took an x out of each end of the length. So our length became generalized as 11 minus 2x. And likewise, we took an x dimension out of each side of the width. So the generalized dimension of the width is 8.5 minus 2x. We can take that equation for the volume of any rectangular prism with any cutout and put it into a calculator. And there's the equation, 11 minus 2x, that quantity, times 8.5 minus 2x, that quantity, times x. And we can graph this. And there's the graph of the equation with the various volumes. This curve will calculate the volume at any cutout. We start at a cutout of 0. We have no volume if we have no height. And then 1 inch, 2 inches, 3 inches, 4. Notice what happens when we get to 4.25 inches. We've basically cut the paper in half, and we've got no width anymore, so we've got no volume. So the place for the optimal cutout is going to be at the peak of this volume graph, and we can let our calculator, the graphing function in the calculator can get us that optimal volume. I'm going to press the second button, calculate, and I'm going to look for, it's called the maximum. Option 4. And then I've got this little spidery thing. I have to position it so it surrounds that maximum point. So I have to be somewhere to the left of it. And then I'll arrow over to somewhere to the right of it. And 1.5854201 is the cutout that will get us the maximum volume. From the 1.58 inch square cutouts, we have not only a design solution, we have the design solution that will optimize that 8.5 by 11 sheet of cardstock paper into a shape of optimal maximum volume. Hope you had fun.